Sir, we are discussing about type.
Huh? Yes, am I audible?
Sir, you're audible, sir. We are at a dipole, sir. We are discussing.
Dipoles. Okay, fine. Okay, now. So till now we have seen electric field due to dipole. Okay. Do you remember what is electric field due to dipole? Taken down these formulas? Yes, Evant.
Sir, copy, sir.
Hello.
Up to this corner, copy it, sir.
Fine. Now, for dipole at a general point, what we can do for dipole at a general point? See, for having dipole moment at a general point, we will divide, or we can say we will take the components of electric dipole in two ways, such that uh, one component of the dipole moment is along the line joining that point from the center of the dipole, and another component is such that it is perpendicular to the dipole. It is perpendicular to the line joining the center of the dipole. Okay, like this. See, this P. Able to see this diagram?
Yes, sir. I can see, so that I.
Now see, earlier we were given these two charges minus q and plus q. In these two charges minus q and plus q, there was a dipole moment P. This is the dipole moment P, this red one. Okay, from negative to positive charge. We took its component along the line joining the center O to the point P. Are you able to see this line, dotted line?
Yes, I got it, sir.
No, I'm asking, are you able to see this dotted line?
Sir, I can see the dotted line, sir. OE
Okay,
line.
from O to point P, not E. P is the point. Okay, from point O to point P, this line is joining. This line is joining the dipole. The dipole center of the dipole with the point P. Now what is happening? Now at point O, the dipole moment is directed from negative to positive. So when we join the line, this line is making an angle theta. Okay, this line OP is making an angle theta. So one component of the dipole moment we are taking along this line OP, and another component of the dipole moment we are taking perpendicular to this line OP. Okay, so P sine theta component will become perpendicular and P cos theta component parallel or along the axis of the dipole. P cos theta is now in which position? Equatorial position or axial position? It is now axial position. This is axial position now, and this is equatorial.
Yes.
This is equatorial position. Okay, and that is
Yes,
axial position. Got it?
I got it, sir.
Now, now we know both formulas. We know the formula of axial position. What is the formula for axial position? And what is the formula for equatorial position? We know both of them. Okay. For for axial position, it is 2 kp upon x cube.
Yeah. So, ఏంటి ఇవన్నీ వైర్లు?
2 kp upon
హైబ్రిడ్
x
ఫ్లైట్
cube.
బ్రో.
This is for axial
బంగారం ఎడ్జెట్
position.
కమ్ముకోగా.
So 2 kp cos theta upon x cube. It is for axial position.
ఎవరు పడేయక
And
పనికిపోయిన ఇంట్లో.
At axial
Wonderful.
position, the electric field will be Kp sine theta upon x cube, because this is the dipole moment at equatorial position. In equatorial manner, the dipole is given to us. So net electric field will be how much? Net electric field, when the both of them are perpendicular to each other, net electric field will be given by taking their resultant. So resultant will be what? E1 square plus E2 square. Okay, we put both of them here, and when we solve it, we are getting 4 cos square theta plus sin square theta. So 3 cos square theta plus 1 we are getting, because cos square theta plus sin square theta is equal to 1. So 3 cos square theta plus 1 we are getting under root, and Kp upon x cube. This is what we are getting for the dipole at any general point. Got it now? Are you writing
I
it
got
down?
it. Sir, why we can't directly find by taking
Huh?
electric field due to two charges separately and directly we can find the resultant we can find this.
That would be become much larger. That would become much larger, because ultimately you have to follow all the process which we have followed earlier in both the cases. Okay, and then you have to use approximation, because generally the dipole is very small. Okay, when the dipole is very small, you can use the approximation you have to use. So ultimately you are getting this
లేదని
formula
చెప్తే
only.
పోయి చావాలా.
So better we use the previously derived formulas. Okay, next. Now some important points. For P on axial line, for point P on axial line, theta is equal to 0. Okay, what will be the electric field? Means this formula is main formula. Now from this formula, you can derive both the formulas for axial one and for equatorial one as well. Okay, Kp upon x cube into 1 plus under root 3 cos square theta. Okay, now for point P on equatorial line, theta is equals to 90 degree. Therefore, net electric field will be equal to Kp upon x cube into under root of 1 plus 0, because cos 90 will be equal to 0. Okay, so we are getting Kp upon x cube, that is for equatorial, and for axial we are getting 2 Kp upon x cube. Just remember that Kp upon x cube and 2 Kp upon x cube. Okay,
Yes.
now if alpha is the angle made by net electric field with the OP vector, then what will be tan alpha? Then tan alpha will be equal to perpendicular component divided by axial component. So sine theta divided by 2 cos theta, sine theta divided by 2 cos theta. What you will get? You will get tan alpha equals to 1 by 2 tan theta. What is alpha now? Alpha is the angle made by electric field. Alpha is the angle made by the final electric field. Okay, got it?
I got it.
Now, try solving this question fast. You have 3 minutes. Find out the electric field for a dipole moment of 6 microcoulomb meters at a distance of 5 centimeter from the center of the dipole at an angle of 53 degrees with the direction of dipole moment. Values in the question. What is the in which formula you are going to put? General
KP by
formula,
X
Kp upon x cube
is the
into
general.
1 plus 3 cos square theta. That's it. When you solve it, answer will come out as 6.2 into 10 to the power 8. Okay, you have to calculate
Yes.
it precisely. Okay, Now next question. In this next question also, same thing is being done here. The question is, an electric dipole has two charges, each of magnitude 1 microcoulomb, 1 centimeter apart from each other. Find the electric field at 10 centimeter from the midpoint on the axial line. On the axial line, what is the formula for electric field due to dipole moment? 2 kp upon x cube. Okay, but here one thing is, the dipoles, they are 1 centimeter apart. So here we cannot use that formula 2 kp upon x cube. Why? Because it had an approximation. X should be very smaller than the distance between two dipoles. Okay. Now here the distance between two dipoles is 1, and distance of the point is 10 centimeter. 1 centimeter, 10 centimeter. Both are in centimeter. Both are comparable to each other. Okay. That's why we have to use the original formula kpx upon x minus x square minus l square whole square. Now we have to put the values in this, and then we will get 18 into 10 to the power 4 newtons per coulomb. Got it now?
I got it, sir.
Now next is torque on electric dipole. Means whenever a dipole is kept on an electric field, what will happen? See, whenever a dipole is kept in an electric field means what? Lines of forces which are coming out from positive charge and ending inside the negative charge. Okay, am I audible? Please be responsive. Okay,
Sir, you're audible, sir. Sir.
fine. Just say actually yes or no.
Yes, sir.
Uh, timely, because I won't be able to know the Wi-Fi is on or off. Okay. Now torque on electric dipole. See, whenever the dipole will be kept in an electric field, this is the electric field, this blue one. What will happen? Positive charge will face a force in the direction of electric field, and negative charge will face a force in the direction opposite to the electric field. Okay.
Yes, sir. Yes.
Now, because of this, what will happen? A couple will be generated. Couple means what? Equal and opposite force, but which is not directed along the line of action. Same line of action is not there. Line of action are two different lines now. Line of action means along which line the force is being applied. So here plus q charge is pulled away and minus q charge is pulled away,
Dava.
and both
Huh?
of them have a
Yeah.
perpendicular distance from the center of dipole. What will happen? These two charges will start rotating. Means the dipole will start rotating. Dipole will start rotating about its center point O. Okay. If the length of the dipole
Yes,
is
sir.
2L, if the length of the dipole is 2L, then what will be the length of that perpendicular section? L sine theta in both the cases, L sine theta. Okay. Because the total length was 2L. So it is L sine theta. Now we have force and we have the perpendicular distances. Okay. We have the perpendicular distances also,
Sir,
and we have the force. So we can calculate easily the torque. Torque experienced by the dipole is force on any of one charge, either charge. So force on plus q charge multiplied by perpendicular distance from the center. Second is force on minus q charge, force on minus q charge
sir,
into
how can we say the
perpendicular distance.
dipole?
Yes, how can we say what?
Sir, here the dipole is not fixed about that point one of.
See, dipole is not fixed, but the forces are same, aren't they? Force on plus q and minus q. Are the forces same? Are these forces same?
The forces are same, sir, but how can we say that the dipole will rotate
Force
about
is
that
the
point of?
same. Yes. See this you must have studied in rotation. That whenever you are applying force, what will happen? Means if you are holding a pencil and you are applying same force on both the ends of pencil in opposite direction, what will happen? The pencil will rotate around its center. Similarly, here also, the dipole will rotate around its center. Why around its center? Because the forces were equal. Forces were equal. Got it? That's why the couple formation took place.
Yes, sir. Understood,
Done?
sir.
Now,
Done, sir.
okay. So force on either charge, any one charge, multiplied by perpendicular distance from the center. Similarly, force on minus q is same, perpendicular distance from the center. So both of the torques will be directly added. What is torque? Torque is an axial vector whose direction is given by right hand thumb rule. Okay. Now this torque is nothing but q into E into L sine theta. Well, q into E is what? Q into E is the Q into E is the force on charge Q, and L sine theta is what? Perpendicular distance. L sine theta is perpendicular distance. Got it now?
Got it, sir.
Okay. So when we will add them, we will get net torque as PE sine theta. Okay, PE sine theta. Or what we can write it as? PE sine theta can be written as PE cos theta. Sorry, P cross E. P sine theta we can write it as P cross E.
Understood.
Hello. Yes, done.
Sir, done,
Done
sir.
writing it
Sir, copy, sir.
now. Now, some important points. The direction of the torque is given by right hand thumb rule. This we have seen. When the dipole is kept perpendicular, then the force will be maximum because theta is 90 degree. And in opposite case, it will be minimum. Okay. Now next is when the dipole moment is parallel to the electric field, that what will be the torque? The torque on the dipole moment will be zero in this case. This diagram I am talking about, last diagram, see it. Okay.
Yes, sir.
Just at the moment, next question is, just at the moment dipole is released, find out the angular acceleration of the dipole. Try it out without seeing anything. Taken down?
Um, sir, copy it, sir.
If it is done, please tell me when it's done.
Sir, it's copied, sir.
Okay, fine. This question, did you get this question?
Sir, this is the company which I have, we can get the answer.
Hello? Yeah,
Yes,
what
sir,
did
I
you
got
say?
this question. Sir, we know that tau equals to alpha by solving we can get not getting for.
Fine, fine, fine. Torque is equals to I into alpha. Okay.
Yes.
Moment of inertia for a straight rod is ml, sorry, 2 ml square. Now, all these questions are of dipole. Mm, Now, if the dipole is kept in non-uniform electric field, then what will happen? Yes, Hemant, I'm asking you. The dipole is kept in a uniform electric field. What will happen?
We can see that it will rotate and it will move and rotate. It has both, you can say, linear and angular.
Both, yes. It will move, means translatory motion and rotatory motion both will be seen. Both translatory and rotatory motion will be seen, because translatory motion will be seen because the charge, one charge will be closer, so it will have larger force, and another charge will be little bit farther, so it will have, it is not
Somewhat
that
extend.
much close. Yes, it is not that much close, so uh, some extra force will be there on the on one of these charges, whichever is closer to the electric field, means higher electric field region. In higher electric field region, whatever charge is present, it will experience larger force. Okay, got it now?
Yes, sir. So got it.
Hmm. Now this here I gave you as a, I tried to give as a question, that two dipoles are there, means two poles are there like this. Okay, and electric field is like this again, as shown in figure. Now in this case, what will be the net force? Net force will be P into dE by dx. dE by dx is what? dE by dx is differentiation of E with respect to x. Got it?
I got it, sir.
Now tell me something about electric flux. What do you understand by this?
Basically, it's a number
Yes,
of lines.
number of field lines passing through the area. Okay, which kind of area?
It's just
Yes,
perpendicular.
yes. Now, and what is its mathematical representation? Mathematically, electric flux phi. What is phi? Yes, mathematically, what is electric flux? How can you define phi in mathematical terms?
We don't know, sir.
See, First of all, phi is a scalar quantity. It will have a direction. Okay, that is clear to you. And
Yes,
that
sir, it is
direction
clear.
is perpendicular to this plate.
Then how can
Now,
area cancel dimensions?
area is considered a vector in physics. How? Because we can always assume that the two vectors which are joining together, they are forming lines of a parallelogram. We can assume that. And when we assume that, the things become quite easy. That's why we do so, otherwise, no need. Okay. Now, area is
Yes, sir.
A square is AB into BC. See the diagram. AB into BC. Now, what is AB into BC? AB is, yes, AB cross BC. This is area. This will come out as AU sine theta. Okay.
Yes,
It
sir.
means what? A square K cap or minus K cap. For open surface, we can take both of them. But for closed surface, we can take only one component which is outside the spherical body. Okay. Now, some special cases. If electric field is normal, then what will happen? Then the flux will be maximum. If the electric field is parallel, then how much flux will be there? Then zero flux will be there because no electric field line passes through that area. No electric field line is crossing that area. Getting my point? Because the plane is horizontal, that's why no electric field line is crossing that area. Fine. Shall we move ahead?
Fine. Yes, sir. Very good.
Now, most important thing, if the flux is to be found out, but the flux is due to non-uniform electric field because of flux here is of non-uniform electric field, is it not? Yes, Chanak, am I audible? Oh, sorry,
Sir,
Hemant.
you're audible, sir. Yes, 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 you're audible.
Hmm. Okay. So in this case, what will happen? For finding the total flux of electric field, we will perform the surface integral of electric field, E dot ds. Can you see this small s written over this integral sign? This small s
Sir,
represents the surface integral of electric field. Okay, got it?
sir, got it, sir.
Next, flux through a closed surface. If a closed surface is there, what will be the flux through that surface? The total flux through that surface is coming out to be q upon epsilon naught. This was asked in questions several times, that prove that the flux through a spherical ball will be this much. Okay,
Amma, Amma, Amma మీద ఒప్పమ్మా.
got it now?
కాబట్టి
Now,
ఇట్లా
let us assume that
చెట్లు
there is a
తెచ్చుకుంటూ
spherical
పోవచ్చు.
ball and this ball is having a charge small q which is placed at the center. Flux through the spherical surface will be, what will be the flux to the spherical surface? We will use that formula, integral of
ఏరియా
E
ఏంటి?
dot ds. Yes, integral of E dot ds, we'll use that formula. What is ds? ds is ds cos theta. Now, integrating s will give us total surface area. As soon as we are getting total surface area, we are getting phi is equals to q upon epsilon naught. Most important formula. Phi is equals to q upon epsilon naught. Okay. Got it now?
I got it.
Okay. Now solve this question. See this question and solve it. Draw the diagram. Here you need to draw the diagram first. Entering the circuit minus flux leaving the circuit. Okay. Now how much flux is entering? E naught x square flux is entering. Okay. So at line x equal to 2a, there will be another electric field, and at line x equal to b, not b, let's write it as x equal to 3a. Then also we can define flux. Total flux entering inside and total flux leaving it. So total flux entering inside is E dot A. It means E naught x square multiplied by x square, and E dot 2A square dot A square. When you will solve it, what are you
Cinema,
getting? What you will get? You will get 5 E naught
yeah,
A to the power 4. Means 5 A to the power 4 E naught. This will be the electric field. 5 into 10 to the A to the power 4
understood.
Yes, now you got the question.
So got the question.
Yes, any doubt?
No doubts.
Fine. Similarly, see, this question is find out the flux through all the surfaces. Okay, now electric field is coming from only uh, negative x direction towards positive x direction. So what we will do here, we will make the directions or surface area vectors of each vector. Okay, like these arrows, blue arrows, they are depicting the directions. Similarly here, this was predicting the direction. Okay, so what will be the flux now? For calculating the flux through first surface, second surface, third, fourth, fifth, and sixth, always remember that the flux which is along the parallel paper means, what do we mean by parallel paper here? See carefully, electric field lines are coming like this. So this one, similarly the bottom, and that backside face is now parallel to the electric field. Okay, these areas which are parallel to the electric fields will have zero zero flux. And the next thing is that electric field is constant here. When electric field is constant, what will happen? Total flux entering is equal to total flux leaving. So net flux is equal to zero here in this question. Got it?
Got it.
Now, see this question. This is important question. Find out the flux due to a point charge q through a disk of radius capital R at a distance L on the axis of the disk as shown. A disk is there, a plate is there, and from this plate at a distance L, a charge plus q is kept. What will be the flux? You need to calculate the flux. Calculate it now. Yes, now, how are you doing? Yes, Hemant. How are you solving
Yes.
it?
Can't find some of
See now, what is the flux, Chanak? Hemant, what is the flux? For finding out flux, again we will consider a elemental
EDS
part.
per month. This is
Okay.
small.
Now, area of this elemental part will be 2 pi r into dx. because it is two-dimensional, so it must have an area. Now this elemental area is as acting as our base for finding electric field. Means electric field is equal to what? The field due to ring. And field due to ring is kq upon x square plus l square. D phi is also due to the same flux. Therefore, d phi is what? E dot ds or E ds cos theta. Okay, everything we shall put in brackets. Everything
And
we shall put
integrate
in
with
this formula, and then we shall integrate. What we need to integrate here? We only need to integrate x. Now again, to integrate x, we have two methods: substitution method and by Eilert method. So substitution I have used here. When you substitute, what will happen? Then
this is all.
no, this is the electric field finally. Okay, at the center of a hollow sphere. Now there it was only a disk. Here it is what? Here it is a conical section. Here it is a conical section. That conical section, that conical section is obviously derived from what? It is obviously derived from a larger sphere. In this larger sphere, the center, three-dimensional, 3D center, 3D, three-dimensional solid angle, which is at the center, that angle we are assuming it to be phi. Okay, so 2 pi 1 minus cos phi is equal to 2 pi into 1 minus L upon under root of L square plus R square. Now, we already know that 4 pi is having full flux through it. Means when the ball was complete, charge was kept inside. The flux was what? Q upon epsilon naught. Okay. But for 1 radian, this was for 4 pi radians. Value of flux was Q upon epsilon naught. For 1 radian, Q upon 4 pi epsilon naught we are getting. Okay. Got it now?
Okay.
Therefore, what will be the flux when ohm st radians are there? Multiplied by ohm. Ohm st radians are there, then multiplied by ohm. And what is ohm st radians? Ohm st radians is the solid angle made at the center. Solid angle made at the center.
Yeah.
Okay. 2 pi into 1 minus L upon R L square plus R square. We got it from here. 2 pi into 1 minus cos phi. Phi is what? 2 pi into 1 minus cos phi. Okay, when we solve it, just now we have the answer. Got it now?
I got it, sir.
Now, Gauss's law of electrostatics. Gauss' law states that flux is directly proportional to charged and closed. That's it. Nothing else. Flux is directly proportional to charge enclosed. This is the Gauss's law. Now, I think you have this file with you. So just go through the Gauss law once and from here we shall continue tomorrow. Okay?
Yes, sir. Obvious.
Are you getting the things? Please, one thing
Hundred.
is I'm requesting. Please solve the examples whatever are written in these notes. They are very good examples, and we need to see them. Okay?
Yes, sir. Obvious.
Fine. Okay, then thank you. We will continue from here in our tomorrow's class, and our today's class is at 7:30 for optics. Okay?
Yes, sir. Obvious.
Fine. Thank you. Thank you so much.
Yes, thanks.